Thank you. My name is Andrew Dessler, and I am a professor of atmospheric sciences at Texas A&M. In my testimony, I will review what I think are the most important conclusions the scientific community has reached in over 2 centuries of work on climate. First, the climate is warming. By this, I mean that we are presently in the midst of an overall increase in the temperature of the lower atmosphere and oceans spanning many decades. Second, most of the recent warming is extremely likely due to the emissions of carbon dioxide and other greenhouse gases by human activities. This is based on several lines of evidence, including observations of increasing greenhouse gases in our atmosphere, an understanding of the greenhouse effect, and a demonstration the enhanced greenhouse effect can explain the observed warming. For simplicity, in the remainder of my testimony, I'm going to refer to this mainstream theory of climate influence as the Standard Model. The Standard Model, in fact, can explain just about everything we observe in the climate system, both present day and during the geologic record. And it has also made many successful predictions, which are the gold standard of science. If you can successfully predict phenomena that are later observed, one can be supremely confident the theory captures something essential about the real world. So as an example, climate scientists predicted in the 60s that the stratosphere would cool while the troposphere would warm as a result of increased greenhouse gases. And this was observed 20 years later. In the 70s, climate models predicted the Arctic would warm faster than the Antarctic. This has also been subsequently confirmed. The water vapor feedback is another fundamental prediction of the Standard Model that has just recently been observed. This explains why the bulk of the scientific community is so confident in the Standard Model. It explains just about everything, and it makes many successful predictions. Now, you don't hear about this very often because scientists don't like to talk about things we know. I'm uninterested in things we know. I like things we don't know. That's research. That's things where we can get stuff done. And I should also add that obviously this doesn't mean our knowledge is perfect, and this is reflected in uncertainty estimates that are provided in the consensus reports. Now, a caveat. I said above the Standard Model explains virtually everything, which means that there are a small number of observations that aren't necessarily well explained by the Standard Model, just as there are a few heavy smokers who don't get lung cancer. An excellent example of this is the so-called hiatus, which has been mentioned several times, slow warming of the surface temperature record over the last decade or so. This is frequently presented as an existential threat to the Standard Model, but as I described below, this greatly exaggerates its implications. Before I explain why, I think it's worth recognizing that skeptics have a track record of overstating the importance of these challenges to the Standard Model. A few years ago, for example, strong claims were made about the surface temperature record. It was argued that siting issues, for example, a thermometer too close to a building, meant that the surface record was hopelessly biased, and this was portrayed as an existential threat to the Standard Model. Subsequent research, however, has resolved this issue, and it is now clear there was never a threat to the Standard Model at all. So why do I think that the hiatus, the slow warming of the last decade, is not much of a threat to the Standard Model? To begin, a lack of a decadal trend in surface temperatures does not mean that the warming has stopped. Observations show that heat continues to accumulate in the bulk of the ocean, indicating continued warming. Also, in my written testimony and in a plot that Senator Whitehouse showed, the surface temperature record shows frequent periods of short cooling, even while it's undergoing a long-term warming trend. In addition, one of the senators said that climate models do not predict periods of no warming. That is not correct. Climate models do predict periods where there is no warming. Now, that does not mean that we understand the hiatus perfectly. And I view the hiatus as an opportunity, not as an existential threat. I think short-term climate variability is an area where our understanding could improve, and the hiatus will help us to do that. Papers are already coming out on a monthly basis, it seems. I suspect that in the next few years, our understanding of this phenomenon will be greatly improved. At that point, I predict that arguments about the hiatus will disappear, just like arguments about the surface temperature record have. Now, given the success of the Standard Model, what does it tell us about the impacts of future climate change? Before I begin talking about this, I think it's worth discussing the value of talking about what we know rather than what we don't know. Focus on what is unknown can lead to an inflated sense of uncertainty. For example, we don't know the exact mechanism by which smoking cigarettes causes cancer, nor do we know how many cigarettes you have to smoke to get cancer, nor can we explain why some heavy smokers don't get cancer while some non-smokers do. Based on this, you might conclude that we don't know how much about the health impacts of smoking, but that's wrong. So let me just conclude by telling you a few of the certain impacts of climate change. We know the planet is going to warm. That's virtually certain. We know extreme heat events will become more frequent. We know the distribution of rainfall will change. We know the seas will rise. We know the oceans will become more acidic. We can argue about things we don't know, but those are things that are virtually certain. Thank you.